Section 15, question 7. Triangle ABC has coordinates A2 1, B10 1, C4 7. Find the equation of the median CN. So remember that a median is a straight line. To find its equation then, it would be point and gradient. Now, a median is a straight line that comes from a vertex. So that's the corner of the triangle. In this case, that's C. And it cuts an opposite line in the middle. So the first thing that I'm going to do is find the midpoint of AB. So for midpoint, that's x1 plus x2 over 2, y1 plus y2 over 2. So that's 2 plus 10 over 2, 1 plus 1 over 2. 2 plus 10 is 12, 12 over 2 is 6, 1 plus 1 is 2, 2 over 2 is 1. So my midpoint then for n is 6, 1. Now I'm going to find the equation of the median. I've got 2 points that lie on the line, so I can find the gradient. That's y2 minus y1 over x2 minus x1, so 1 minus 7 over 6 minus 4. That's minus 6 over 2, and the gradient of median is minus 3. So if I've got the gradient, and I choose one of the points, I've got 2 points, so I'm just going to choose one at random, which is 4, 7. Y minus b equals n bracket x minus a, and that's y minus 7 is equal to minus 3 bracket x minus 4. That's y minus 7 equals minus 3x plus 12. Bring that across, change side, change sign, that's minus 3x plus 19. Part B says find the equation of the altitude AD. Says the altitude AD. Now an altitude is a straight line, so we need point gradient. We've already got point, which is 2, 1. Now we need to find gradient. Now an altitude, let's have a think about an altitude, what type of straight line it is. So an altitude comes from a vertex, comes from a corner of a triangle, which is here at A, and it cuts the opposite line at a right angle. So this is going to be a bit of m1, m2 equals minus 1. So to find the gradient here, I'm going to first of all find the gradient here, and m1 to equals minus 1. So I'm going to first of all find the gradient of CB. So that's m equals 1 minus 7 over 10 minus 4. That's minus 6 over 6, and that's minus 1. It's then m1, m2 equals minus 1 to find the gradient of the altitude. So flip and invert, minus 1 over 1, flip it over, becomes plus 1 over 1, and that's 1. Look at the point that lies on the line, which is 2, 1. We can sub that into y minus b equals n bracket x minus a. So that's y minus 1 equals 1 bracket x minus 2. That's y minus 1 equals x minus 2. And bring that over, and that'll be y equals minus 1. Part C says the median from A and altitude from B intersect at a point B, P rather, so that's that. Find the coordinates of the point P, so it's just simultaneous equations. So my first equation was, and that was for the median, y equals minus 3x plus 19. Second equation for the altitude is y equals x minus 1. So I'm going to get rid of y's by doing 1 take away 2. Y take away y is 0. Minus 3x minus x is minus 4x. 19 minus minus 1, and that's 20. So 4x equals 20 and x equals 5. I'm now going to sub x equals 5 into one of the equations, and I'm going to choose equation 2. So y equals x minus 1, that's 5 minus 1, and that's 4. So my point of intersection then is 5, 4. Part D says the point Q lies on AB and has the coordinates 8, 1. Show that PQ is parallel to BC. So that was the point P. So there's PQ, and we're looking to show that that's parallel to BC. So parallel, we would prove that if the gradients are equal. So we've already worked out that the gradient of BC was minus 1. So what we should find now is that the gradient of PQ is also minus 1. So there's the point P, there's the point Q. So gradient of PQ is 1 minus 4 over 8 minus 5, it's minus 3, and there you go, that is minus 1. Alright, so what I would say at this point is parallel since gradients are the same, both minus 1. That's the final answer to the question.